expected value of x, and they give us something about the probability distribution up here. The big idea you want to use to figure out what that letter C is the fact that if you add up all the probabilities of each individual possible event, it should make one, right? If you're playing a game and you add up all the different probabilities of all the different options, it should make 100% because you got to get one of those possible options in the game. Same thing with probability, okay? So probability that x equals 1, so the probability that capital X equals 1 is going to be C times 1. So we're going to do C, here I'm going to type it out. C times 1. And so the probability that x equals 2 is going to be C times 2. If I add all these options together, there we go. C times 2 plus C times 3 plus C times 4. These are all the different probabilities they tell us, and it must equal 1 because these represent all the different possibilities, right? Just like, trying to think of something other than dice. Like, there's 6 sides on a die, right? If you add the probability of getting a 1 plus the probability of getting a 2 plus the probability of getting a 3 plus the probability of 4 plus the probability of 5 plus the probability of 6, it should add up to 1 because you've got every possibility. The probability that x equals 1, according to this problem, is equal to C times the number 1, according to the formula up here. Okay. I can't get this box to go away. There we go. The probability that x equals 2 is C times 2, because it says it right here, C times 2. So if we add up all those individual probabilities, it should make 1 because we've added every possible option. So I'm just going to simplify this, put it in normal algebra terms, put the number out front. And those are all like terms, so 1c plus 2, that makes 3c, 6c, 10c. So if we solve for c, c is 1 over 10. So we know what that constant c is. And now that we can more properly define each probability here, let's write it out. The probability that x equals 1 is c, which is 1 over 10, we just found out, times 1. And the probability that x equals 2 is equal to c times 2. The probability that x equals 3 is equal to c times 3. Just using that formula right there, plugging 3 in for x. The probability that x equals 4, our last option, is 1 over 10 times 4. So now that we know each probability, we can compute the expected value. The expected value of an event is equal to the value of x times the probability of getting that x. Okay? And this is the probability that we get x equals 1 from that blue table I have right there. And then the probability of getting it, so the next value is 2, and the probability of getting a 2 is 1 over 10 times 2. And then the next value is a 3, and we multiply that by the probability of getting a 3. And then 4, and then the probability of getting a 4. Just kind of spilled over. There we go. Okay, so if we simplify that, we'll have our answer, the expected value of x. So the first one, 1 times 1 over 10 times 1, that's just 1 over 10. Second one, 2 times 1 over 10 times 2, that's 4 over 10. 3 times 1 times 3, that's 9 over 10. And then the last one's 16 over 10. So I'll have common denominators, so 1 plus 4 makes 5, plus 9 makes 14, plus 16 makes 30. So the expected value of n is 3. So two things happen there. We need to know how to find C using the fact that all probabilities have to add up to 1, like I did here. Probability of the first plus probability of the second plus probability. That's how we solve for C. And then we need to know what an expected value is. An expected value is where you take the value of each x and multiply by its corresponding probability, which we get the probability from this formula.